all the people from the HTS and other companies were signed up to hear this webinar. It's actually a talk, HTS talk, dinner talk to the international group of the HTS. It's called Revisiting the Cretaceous Play of Trinidad. The man that's giving the talk is Xavier Moonan. He's the exploration manager for Touchstone Exploration. Xavier spent several months working with me on the Southern Basin, right in the same office, same room. So I know him quite well. He's a very good geologist. He's well known throughout the Latin American region. So I'll give you a little basic resume of Mr. Moonan, which doesn't do him justice. He has about 15 years of experience working as a petroleum geologist, exploration, development, operation, the whole thing, in all the sedimentary basins and subbasins onshore and offshore Trinidad and Tobago. His professional experience includes work with Geoservices Schlumberger, former state-owned Petroton, which has changed its name to Heritage now, and a UK-based gas company called Centrica Energy. In addition to his role at Touchstone, he supports the Petroleum Engineering Program at the University of Trinidad and Tobago and the Petroleum Geoscience Program at the University of West Indies St. Augustine campus through lectures. And actually, a lot of people from Trinidad and Tobago Geological Society went to that University of West Indies. He's also a member of the European Association of Geoscientists and Engineers, EAGE, and the Houston Geological Society, HGS. Member of the Geological Society of America, GSA, Society of Petroleum Engineers, SPE. He was awarded in 2021 the AAPG Grover E. Murray Distinguished Educator Award. They should tell you something about him. He's a very good speaker, better than me, actually, but most people are. Mr. Moonan holds a bachelor's degree in geology from the University of West Indies Mona campus in Jamaica, and then he went on for a master's degree in structural geology with geophysics from the University of Leeds in UK. And I'll say this about him: he took the short form of that master's degree. I think he did it like a year, which is unknown. It's just a real mind stretcher, and he got through it with flying colors. So I'll give you Mr. Moonan, exploration manager of Touchstone Exploration, on revisiting the Cretaceous play of Trinidad. Go ahead.
Thanks, Steve. Thanks so much. And yeah, it's an honor to present again for the Houston Geological Society. I remember when I was working with Steve, I did my first talk for the HGS there, where I talked about the penal barracuda play, which was actually part of my my master's thesis from Leeds. So yeah, let me introduce you to Trinidad, right? So those who don't know, Trinidad is located in the southeastern part of the Caribbean, and it's pretty much being influenced by the easterly motion of that Caribbean plate, of course. As you could look at the cross section that you see down at the bottom left here, a section that goes pretty much across the island from northwest to southeast. You see pretty much like a passive extensional sort of basin in the northern part of the country, followed by a pretty severe fold and thrust belt to the south of it. Cretaceous rocks highlighted in that cross section are in green. And then you got a younger detached play, which sits in the Oligo to mid-Miocene packages above that. Most of those rocks are then covered up by deltaic deposits, which arrived from the Orinoco Delta through a series of transgressive and regressive packages. And they basically pushed the source rock. For the greater part, if it wasn't already in the oil window, it pushed it into the oil window at that point in time. We've been in the oil business for quite some time, right? We had one of the first oil wells drilled back in 1857, though it was not commercial. And since then, we've drilled 13,000 wells or so and produced quite a lot of hydrocarbon. We moved from an oil-based economy to a gas-based economy now. And most of those hydrocarbons are produced from Plio-Pleistocene deposits. The Cretaceous has been penetrated throughout Trinidad, but very rarely. And I'll show you on some subsequent maps how sparsely it has actually been drilled. But what is really the Cretaceous play? And I remember Bob Ehrlich, great guy. He did some really great work on the Cretaceous with fellow folks in Trinidad. And he had a similar talk where he was discussing the Cretaceous play and basically the mindset of how the play developed in Ghana the 10 complex and worked its way across to the discovery in French Guyana. And then that led on to the to Exxon's exploration effort in English Guyana, British Guyana right now, right? So that's where the hotspot really occurs right now. But I think just to highlight what I'm going to focus on in terms of what the Cretaceous play means in this context is that we're really looking at the deep water turbidites, which are of Cretaceous age. Most of them are late Cretaceous in age. And they are basically interbedded, basically encased in deep water shales. And in this case, we have both stratigraphic traps as well as structural traps in some places. And the source rock itself is this Cretaceous deposit, right? So the fetch itself is coming from the same rock. And in the Guyana-Suriname area, most of these turbidites, as they were shed from the continental shelf, they have been deposited quite extensively across the area, as you would have seen the amount of discoveries they've made there now. Very large fan systems. And most of those sands are being sourced directly from the Proterozoic Guyana Shield, which are some of the cleanest quartz-rich sands you could ever ask for. So really great quality reservoirs, multi-Darcy producers, right? And in this case, those sandstones are then encased in shales and then were subsequently buried by thick deposits from the Amazon River system, which pretty much pushed that entire area into the oil window around the Eocene also. And that's really what led to a lot of hydrocarbons being trapped there, predominantly stratigraphic traps with some structural draping straps, but largely undeformed. On the flip side, in Trinidad, we have pretty much the same depositional systems, right, as shared in Guyana, Suriname area. But we had a subsequent, of course, as what I've alluded to from the cross-section I showed you, a lot of deformation that came thereafter due to the arrival of the Caribbean plate into the area. So the Cretaceous traps or stratigraphic traps were largely folded and refolded into various features, right? So that makes the play even more difficult to work in the Trinidad area, but can it work in some places still? So like I said, most of the hydrocarbon comes from very young sediments, Plio-Pleistocene in age. The Cretaceous is down here. That is our source rock, the Naprima Hill, the Gautier, these deposits. And they pretty much overlie Couvreux evaporite, which is of Callovian in age. So I think first to start with, maybe just to introduce you to the whole perspective of the country. On the northern side, why don't we explore the northern side? Well, it's mainly metamorphosed allochthonous Cretaceous and Jurassic deposits. There are mostly deltaic and they also incorporate refall sediments. The northern basin itself is lacking of that Cretaceous deposit, the Naprima Hill and Gautier formations. There have been put forward a few theories for such as either non-deposition altogether or significant erosion of that of those deposits. And then we move to the central range area. Here we have the Cretaceous deposited. It actually occurs at surface in some places. So around over here, you see some of these green bands running through the central range. Here we have Cretaceous at surface. There's a place called Chert Hill. We have chert deposits within the Cretaceous, bedded cherts, telling you about the sort of deep water depositional environments. And then up at San Fernando Hill, which is very popular, the southern city, surrounds a Cretaceous a pop-up transpressional feature, and that's the most popular Cretaceous outcrop of the area. It is mature over here. It's actually leaking out oil at the site itself. So it's mature and over mature in some places. It occurs at very variable depths throughout the central range area. Some places really near surface, and some places it's quite deep. Moving on to like the southern basin area, as we it's pretty mature. We have quite a lot of oil derived from it, 13,000 feet thereabouts. And as we move even further towards the southern range, it gets pretty shallow in this area. The deposits occur at 5,000 to 7,000 feet. There are significant nonconformities above it, and the area seems to have been uplifted quite a lot. On trend with the central range, we have an area commonly referred to as the Brighton High. Here again, large unconformity, and the Naprima Hill comes in at around 7,000 or so feet. So some of the things that you look for as well, okay, well, where is it? There is it. That's where the rocks tend to occur. And of course, like I said, they are variable. They are at variable depths, and they have undergone variable amounts of maturity. So where has it actually been drilled onshore? So you probably have to focus on the green dots in this picture. This is from Jim Pindell's work across the southern basin of Trinidad. So I've just added on a couple wells to this since his publication. So you would see that there's a cluster of wells in the Brighton area towards the west, or the left part of the image that you're seeing. And then you have a cluster of wells to the south. And pretty much that's where we have Cretaceous deposits quite shallow again, as you see some depths there, 4,000 or 5,000 feet or so, generally speaking. There's some wells I've also put on some stars.
Xavier, we can't see your pointer.
That's correct. I was trying to say that myself.
Okay.
You can get down to the left and pick up the pointer there, I believe.
You see it now?
Now we can see it, yes.
Okay, sorry about that. Yep. So down to the right-hand side of the image, you see some Cretaceous wells over here, and they've penetrated the Cretaceous, between 5,000 to 6,000 feet or so around here. I've highlighted some wells with stars across the area, and some of those we're going to be talking about in more detail. There's some of the more recent wells that were drilled to the Cretaceous. When I say recent really means like from 1990 to present, right? So for the last 30 years or so. And I've also highlighted on the Ottawa block, which is an area that we'll talk about a little bit. Here's a Cretaceous play map that was generated from Exxon's work across the area. So Exxon basically would have acquired 2D seismic across the area every 2 or 3 kilometers. And then they would have then tackled a couple sites highlighted here. So of those sites, we will be talking about the 3 wells that they would have drilled. And then further to that, Talisman would have then tackled the Cretaceous up in the eastern block area highlighted up here towards the right-hand side of the image. And they shot a 3D seismic survey in that area and tackled 2 Cretaceous plays around there. From a depositional standpoint, what the image also shows is that there are a few wells scattered across the area that actually found sandstones in the Cretaceous, and these are all interpreted to be deep water turbiditic rich sandstones. So in this area, there are some sandstones. Across here, there's a trend of sandstones here, and of course up here. But yeah, there are quite a lot of Cretaceous wells that actually found pretty much no sandstones altogether, right? And here's a time structure map of the area. This was generated by Jim Pindell for the utilizing the same 2D seismic that Exxon would have acquired back in the 1990s as part of the Southern Basin Consortium. So just to show you that, yes, there are Cretaceous structures all throughout the area. It's associated with the fold and thrust belt, associated with the compressional structures, and most of them are expected to have been pretty much positive inverted features that would have occurred along old rift systems. So let's see what we've learned about the Cretaceous. So back in the 1989 period, this is when Exxon, Total, Chevron, and the Trinidad companies, Trintoc and Trintopec, basically came together. They formed the Southern Basin Consortium, and they decided to explore pretty much to follow up like the large discovery made out in Eastern Venezuela at that time called El Furrial. So they acquired 2D seismic across the island. And after acquiring those 2D seismic lines across the island, they decided to tackle 3 wells: Iguana River, Rocky Palace, and St. Croix. All of these wells basically tested Cretaceous fold structures, right? So it's all purely a structurally driven sort of play, right? These structures were well understood from the 2D seismic lines, well, as best as you could from the 2D seismic lines that they had acquired. All of them penetrated sandstones in the Cretaceous, and they were modeled to be deep water turbidites. They were all encased in shales. And the sandstones, however, had residual oils or termed subcommercial accumulations. And the St. Croix well, which is the most northerly of the 3, this encountered the Cretaceous shales. They were found to be mature to even over mature, whereas the Iguana River area towards the south was found to be thermally immature. So that's just some stuff that came out of that whole study with those 3 wells. So let's look at those 3 wells in a little bit more detail now. So the first well, Rocky Palace, it was spudded back in 1993, drilled at 16,006 feet. The source rock was termed to be mature in this area over here. Nearby, I talk about another well, Mon Diablo 34. This is a well that Bob Ehrlich would have spoken to in one of his talks. So here is Rocky Palace, the red star, and Mon Diablo 34, the pink star. This is a northwest to southeast seismic line. It's the 91-177 seismic line, which we've actually utilized as a teaching tool for many of the students in Trinidad. It crosses the Davie Wellington anticline, the Penal Barco anticline demonstrated here in all of these wells, and then the Rocky Palace Solomon anticline, named thereafter because of the Rocky Palace well. So the Rocky Palace well drilled into a mid-Miocene age fold. Mid-Miocene is highlighted here in this green horizon. Those are the Herrera sandstones that people know me about, right? And the Cretaceous, and the well was deepened down into the Cretaceous, and the Cretaceous basically came in over here. It was also found repeated in the well. The Mon Diablo 34 well pretty much drilled a normal sequence all the way down through the Herreras over here in the mid-Miocene package, and then came all the way down to the Cretaceous as well. I've got the stratigraphy of both wells listed out over here, and the thrust fall demonstrated in the Rocky Palace well at the couche level back into the Gautier system. And what did they find, right, on this well? So it was tested in 4 zones. One zone is actually tested in a few different configurations. It produced mostly water, and then they found condensate up to 41-degree API. They found 12-degree API in some places, and they found gas in some places. They got up to like 4 million standard cubic feet of gas in that. So based on those results, they deemed this Cretaceous structure as commercially uneconomic, right? So here's the structure shown in 3 dimensions. Are you all seeing it? Because I've got like the all of the attendees are listed out there, so I assume you're seeing it. So you got a nice anticlinal feature there. The well was pretty much drilled very near the crest of the anticline itself. So based on that, it was pretty much like written off. Here's the log from that Mont Diablo 34 well. This is from Bob Ehrlich's work. And he's demonstrating in here that there are some nice sandstone intervals. There's also a couple carbonate-rich intervals as well too. And here's some pictures of the cores that he also demonstrated. Nice slope channels, right? Very nice, fine, massive sandstone layers, and some areas with channel log deposits. So moving on to the St. Croix well, which is the most northerly of the wells that Exxon had drilled at that time. Pretty much what they found over here was that the sandstones were well, found quite thick. Actually, some of the thickest deposits that of Cretaceous sandstones that they had found in all of the wells. That's this interval down here. They got pretty high resistivities in here as well, right? They did not test this well, right? The sandstones were, the interval was interpreted to be water wet, and pretty much from the core data, they wrote off doing anything further on the well. So the sandstones came in from, let's say 14,000 feet all the way down to pretty much 16,000 feet. So quite a thick interval, but it was interpreted to be very low perm and water wet. And pretty much they interpreted that the trap itself had been breached. When you look at a cross section that was drawn up after, you see the amount of repeat intervals that occurred within the Miocene section before entering the Cretaceous itself, right? And actually, I have the log here. Pretty much is almost scaled to the same as the cross section itself. So a lot of this interval inside here was just rich intervals. No significant sandstones of or backup zones for economic testing. So we then are going to discuss the wells that were drilled by Talisman, with two wells, which were the Zabo Car and Shalabeni wells. And then I'll come back to talk about this guy, Iguana River, which was the second well drilled by Exxon. So at that, Talisman basically came into the country back in the 2000 period, and they acquired a 3D seismic survey. So the 3D seismic survey is shown here in green. That's called the Eastern block. It was acquired with pretty large charge sizes, sometimes between 8 and 12 kilograms. They were hell bent on imaging the Cretaceous in here. That was their main goal, really. And so they drilled the Zabo Car well, followed by the Shalabeni well. So I've got here the stratigraphy of the Shalabeni well to start with. Pretty much they drilled down to 15,000 feet with the Zabo Car well, and 14,006 feet with the Shalabeni well. The stratigraphy of the Shalabeni well shows that you go through, again, the Oligo-Miocene section, heavily repeated, well, relatively repeated, right? And then they entered the Naparima Hill unit down at the base. And then it was interpreted that the Oligocene came in below that again. So it tells you something about, well, the Cretaceous unit that was actually penetrated by this well. It's not the true subthrust Cretaceous plate to start with, right? It's still an upthrusted sheet. And so really makes you wonder, well, if you continue below this, what lies inside that Cretaceous package there? They found some sandstone, so that's good. Not quite thick as you see in Croix sandstones or the Rocky Palace sandstones, but still sandstones nonetheless. There was some gas recorded inside here, but the interval was not tested. They also encountered sandstones, thicker sandstones in an Oligocene package higher up in the well and also a bit deeper in the well. And that became the interval of further interest where they targeted in 2 subsequent wells. So now I bring up the Zabo Car well, which was the first well that they had drilled. And you might ask, well, why did I put up this map in this area over here? Well, this is Bob Ehrlich's map from 2003, and he's showing a fan system that comes out over here. And he's showing where the Zabo Car well relatively is positioned. Of course, this is not all restored or anything. This is just using present day locations and just drawing some blobs to show potential fan systems that are not restored, right? But this well, Zabo Car, actually did not penetrate any Cretaceous sandstones. And the question is, well, why would it not have penetrated Cretaceous sandstones, despite the fact that it seems to be within sand fairway? The reason being is that technically speaking, maybe if they had changed the position of the well and what the well would have the trajectory of the well, they may have penetrated Cretaceous sandstones. How? Well, if you look at the stratigraphy, they did not actually penetrate any of the Naparima Hill, right? So they drilled through very young Miocene all the way through to Eocene package, and then had a significantly stacked Oligomycene section again, right? You see the number of potential thrust faults inside here, repeating that. So pretty much you have to go all the way down to 10,000 feet to potentially get to intervals that may entail Cretaceous packages. When they got there, they encountered the Gautier, right? And the Gautier in this case was shaled out. They encountered the Couche, which is early Cretaceous, and then they encountered the Couche again. Potentially this interval is being repeated in a synclinal position, which suggests to us that because the Naparima Hill overlies the Gautier, and they drilled the well at a slightly different trajectory, they may have penetrated the Naparima. The beds in this case are very steep, and so that's one of the reasons why they will have missed the Naparima package. Further to that, they continued drilling and they got back into Oligo-Eocene packages again, and then a repeat of that again before calling it quits on the well. So quite a long drill, quite a test, but the stratigraphy was structured in such a way that they did not penetrate the Naparima Hill or sand-rich packages in the well. So I'm not writing off that that Bob was wrong by saying that that in this area there should be Cretaceous sandstones. I think it's just due to the amount of structuring that would have occurred there that pretty much you end up in a situation whereby you just miss the package altogether, the particular stratigraphic unit that you need to encounter. So going on to the Iguana River well now. So this was the second well that was drilled by Exxon. And they drilled it all the way out in the southeastern part of the country. So that's here, right? And we've got the red boxes. In this area over here, this area is actually quite well known for shallow gas coming to surface in this area along the Duckham Road. And they basically came down this area over here, right? This area over here, and drilled where the star is located on the map. So what did they find? They drilled to 12,762 feet over here, and they found 2 Cretaceous packages. So the stratigraphy shows you go from early Pliocene all the way through to like early Miocene. There's a very thin, shaly early Miocene package. And then you get into the Cretaceous. So quite an unconformity that exists over there, right? So that was the first Cretaceous package that was penetrated. You got into slightly early Cretaceous, and then another fault taking us back into late Cretaceous again at the base of the well. The source rocks that were tested over here were found to be immature, and no zones were tested. They did note that the Cretaceous packages were, there were sandstone intervals. They were found to be wet due to trap leakage. They also found some limestones in there, but they failed to mention anything more really about the limestones. And that takes me to what you see on the rest of the slide over here, which seems to have nothing to do with the Iguana River well at all, right? So some years later, so this was back in the 1990s, right? In 2017, some hunters were exploring this area over here, and they came across an area on the Kugler map, surface geology map of Trinidad, that said Salt Spring, right? So they happened to go to this area, and they said that, you know, it looked like some sort of oil-rich mud volcano or something, and they asked us to come and take a look at it. So the APG Young Professionals group basically went out there, hiked to this feature. It's quite a hike, and out here, lo and behold, you come out of really thick rainforest jungle, and there's a platform of just limestones, right? So this is 2,4 limestone. So here's a picture of it. It's pretty much a reprecipitated form of limestone. And this is precipitating out of water that is cascading down a hillside over here. So we of course were marveled by this, right? So we took some of it, we made some thin sections of it. We also tested the waters, tested the temperature, and found some pretty interesting things. So yeah, the area was named Salt Spring, and there's a good reason why. The water coming out of here ranges between 16 and 23,000 parts per million. And we tested this on a pretty rainy day, where it was being diluted by rainwater that was falling on us at that point in time. The temperature when we tested was 40 degrees Celsius at surface, and we found that the carbonate content of it was quite high. This is pretty much like 4 times higher than any carbonate content water that we found in any of our producing fields, right? So it's quite interesting, quite different. When we look at it on its thin sections, we basically see it has a stromatolitic fabric. We even see cave pearls within it, and there's even oil inside of it. So not only is there water coming out of the ground that is salt rich, it's also carbonate rich, and it also has oil associated with it. There's actually quite a large pool of oil that forms on surface over here as well too, right? So we see limestones around the area. They've also got cross-bedded silty laminae inside of them. And so it starts to make you wonder, well, is there some sort of carbonate story to this as well too? And that ties into the fact that we also recognize that there's quite a large unconformity that occurred over here based on the nearby well, which happens to be, you know, less than 2 km away towards the east of this area. So what have we learned so far, right? So most of the wells prior to Exxon, and Talisman, they failed to find reservoir. The Talisman Zabo Car well failed to find reservoir as well, but this is probably due to structural configuration because they did not actually get a chance to penetrate the Nakrema Hill formation. The Southern Basin Consortium and the Talisman wells, well, they targeted structural traps, as I showed, and all of them appear to have been breached due to late stage deformation, right? The source rock maturity is generally high to over mature in the central range area, and of course low to immature in the southern range area. Sweet spot is really the southern basin itself. The carbonates are present at Iguana River-1. That's pretty interesting. And the salt spring feature expels carbonate-rich water, so rich in carbonate that it actually precipitates at surface. And there's actually so much water coming out of this thing that it forms a spring, which actually forms a river. Guess the name of the river, Salt River, right? So this is an area more than 20 kilometers away from any coastline. This is not modern day seawater. This is water trapped in formation below the ground. And this maybe is suggesting to us that maybe this area is close to the Paleo shelf edge at Cretaceous time. There's minimal, for this play to work, you really need minimal post-charge maturation deformation. That's the only way it would really work, right? So, which takes me to a prospect that we have. So we've named this prospect the Kraken. It occurs within the central part of the Ottawa block, that block that I just pointed out at the beginning. In this area, what we recognize is that to the south of us, we have the lizard anticline, which is creating quite a backstop, right, feature. And that area got lifted up quite early, hence the large unconformity. So this large unconformity pretty much tells us that the area got lifted up, somewhere during the Eocene or so. And that basically allowed for quite a large time period to pass of no deposition at all on top here. So there were probably some refill or shelf edge carbonates that occurred here during the Cretaceous time, and then this area gets popped up. It even gets eroded. Maybe there's even karst features inside there. I mean, we got cave pearls being preserved, right? So who knows? We shot some new seismic across the area just to the north of it, and we've targeted a mid-Miocene feature out over here that we call Royston. It's also imbricated as well, but not as imbricated as the Central Range area. And pretty much after the late Miocene packages inside here are not deformed. That's very fundamentally different from what we see in the Central Range area. We expect that pretty much what happened from the late Miocene onwards is that the fold belt focused on the Central Range and the lizard anticline as these structures continue to grow toward each other, leaving the Ottawa syncline relatively undeformed and pretty much sitting sheltered between these two moving giants on either side, right? So below this feature that we've drilled over here, we recognize a Cretaceous bump as well too. And this Cretaceous bump is the target that we've called the Kraken. The good thing is that since we've drilled this was our last exploration well into this area over here. We've proven that there's oil in here, and this oil actually types to the type of source rocks that are equivalent to in the Guyana-Suriname Basin. So it speaks well for what may occur down here. But like I said, one of the key risks for this area is, would there be significant reservoir here, and what kind of reservoir would there be, right? We know we got limestone-rich, carbonate-rich shelf to the south of us. Are we really in the heart of a deep water turbiditic fairway to support the Cretaceous plate? I think we have a pretty good chance. So here's just putting it all in perspective. Here's the Guyana-Suriname discoveries out in the Starbuck block and block into block 58 and stuff in Suriname. Here's where the shelf edge turns because of the Demerara Plateau over here. Demerara Plateau is carbonate rich, all on the shelfal areas over here, wells penetrated carbonates as well too. And then I'm telling you up over here in Iguana River, we're also seeing some carbonates as well. The fan systems, as Ehrlich would have alluded to, I have a sort of restored fan system over here now. And that's potentially how those main fans are probably coming off the Paleo Cretaceous shelf edge in this area, in Trinidad part of the world. And we have a pretty sharp turn to the shelf edge due to the westward zipper type opening of the Caribbean at that point. which steps away from the Guyana transform system, which creates the Guyana-Suriname Basin. Here's GeoMark's data where they typed our oils from the Royston well to the Guyana-Suriname plate. So that's pretty interesting that they actually believe that it actually types better to the Guyana-Suriname plate than to the Eastern Venezuela system. So yeah, like I said, Kraken would be pretty much the first onshore Cretaceous attempt in more than 15 years. So for a country, pretty interesting for that to happen. It may be the 7th deepest well ever drilled onshore Trinidad. So that's also pretty interesting too. Here I've summarized, the Rocky Pass well, Iguana River, St. Croix well, all drilled by Exxon, and then the 2 talisman wells, Zabo Car and Shelfal. And so, yeah, again, I'm emphasizing that the key element for success in this play is really for minimal post-charge or maturation deformation. So we know that in the Kraken area, that after being charged over 5 million years ago, the structure just has not moved, and structures on either side have actually moved instead. So just to add to that, so one thing that you probably should do if you're drilling, especially onshore, is to do extensive field work. I don't know if had Exxon done some field work further towards the west of where they had drilled, would they have seen the salt spring feature? It's clearly it has been there for a couple million years for sure. And it's quite a leaky, active, deep-seated fault. So that's pretty interesting. But I'm grateful for the data because we can learn from that. And yeah, just you got to integrate everything you get, right? So seismic, well data, surface geology, field work. That's how you tackle these other plays. So I hope to be able to tell you more about how the Cretaceous has worked out in the coming times, right? So we should be tackling this soon. Yep, thanks.
Okay, yeah, great talk, Xavier. Some questions came in, and I'll relay these questions on to you. I have my own, of course, since I worked this area. First question was the source rock. What was the source reservoir source rock sourcing for the sands in Trinidad, or presumably Guyana platform? He asked where exactly were the sands sourced from. He's trying to relate that to what they have in Guyana.
Yeah, no, it's sourced from the same uplifted Guyana shield system. Yeah, same.
Somebody else asked if you're relying on the Cretaceous source to also source the Cretaceous reservoirs.
Yes, correct. Yeah, the Cretaceous is the key source rock for Trinidad and pretty much for the Guyana area as well as Eastern Venezuela system. Yeah, they are of slightly different ages throughout, but yes, for generally speaking, yes, we're relying on a Cretaceous source rock.
Steve, that was not my question.
Oh, what was it?
I'm sorry, I said question. My question is, if you're relying on a Cretaceous source, so it's the Cretaceous source, right? The La Luna and Aprima Hill, Conje, yep. Right? All Cretaceous passive margin source. Are you yep. concerned about Cretaceous reservoirs having a reservoir quality issue, since you'll have a similar thermal maturation that those reservoirs will encounter in order to have a mature source? That was my question.
No. So how the play works is that we're relying on the Cretaceous source rocks. Yes, the source rocks will basically allow for migration of the hydrocarbons from areas where the source rock is underpinned in the fold belt to the areas where it has been folded, and it actually and those are the areas where we coincidentally would have thicker turbiditic deposits to the south of it, right?
But the structuring is late in that area.
Yes.
So your Cretaceous source is going to go mature because of load, and your Cretaceous reservoirs will be sitting in the same thermal regime. The structuring, though, is at a later date. So I get that for like a Miocene
No, hold on.
reservoirs that it would be going into.
No, so, okay, to peel it back, right? It becomes mature 5 million years ago. The structure formed before that, right? The
One
structure
of the good
formed
things
in
about
11 million years ago.
one of the good things about when you're dealing with all these stacked imbricated sheets is you're getting repetition of source rocks. You're not just looking at one, you look at the same source rock sequences or sequences, but they're stacked. So one may be not quite mature, but you go a little deeper and then you end up picking ones that are up to more mature. I have another question. Actually, I have several questions. When you drilled the Zapata, Shandon Benny, Rocky Palace, what kind of mud weights did you have in the bottom 2,000 feet of the well there? 16, 17, 18 pounds?
Yeah,
What's
yeah,
the mud weight?
they got up to like 17 pounds in some places. Yeah.
Okay, once you hit 17 pounds, it becomes difficult unless you can come up with a massive reservoir. Massive reservoir sheet becomes difficult to get production out of it. 18 pounds is kind of what they call a
Well,
suitcase
yeah.
situation. Is lean.
Luckily, we have got some experience with that, right? Because we've got a pretty massive gas discovery called Cascadera that required such mud weights, and those came in at much shallower depths than what we're talking about here.
Okay, on your Cretaceous shelf margin, is it sitting along the central range? In other words, when you hit the Cretaceous carbonate shelf margins, does it sit right at the central range and you essentially developed a big shear fault going through there, you flower structure up along?
No. So the Cretaceous shelf edge is now modeled to be within the southern range, right? So it's within the southern range, and then your turbiditic systems stem off from that northward, spanning through the southern basin into the central range system.
Okay, I noticed you had that lizard spring platform there. Would
Yeah.
that be the old Cretaceous platform? And essentially you're looking for that? Is that what you're trying to do with lizard springs?
No,
Lizard
we're
springs
not
high.
necessarily looking for that, right? But it's a new data point or a new way of looking at it that maybe they did not actually drill Cretaceous deep water deposits in the Iguana River area at all.
Okay.
Maybe it was all actually outer shelfal deposits.
Okay, she said, I understand what you said, what Patty said. I understand what you said. You do need to consider the main reason for the failure in the previous well was last structuring, and many of the Cretaceous and Eocene reservoirs that have been drilled were tight. Okay.
No,
Yeah,
okay. So those reservoirs were folded and continuously folded, right? Even up to present day, they're still being folded,
yeah.
right? And what we know is that we've got mid-Miocene reservoirs, pretty much a couple thousand feet higher than where the Cretaceous is going to be targeted, right? And the mid-Miocene reservoirs contain oil and they're flowing oil.
I understand that. That's present day charge. I get that concept. The only thing I'm pushing you on a little bit, Xavier, because I am familiar with the area, is just the Cretaceous and Eocene reservoirs. A lot of people have, and I hope there is a great play to be had there. You just have to be careful about the RQ. If you go in and basically do your burial histories, present day exhumation, and you know this isn't going to do anything for you. There's just a lot of wells that have tagged those Cretaceous reservoirs all the way around the passive margin. And it just behooves you to be sure that you've pulled in all the RQ data that's available. And a lot of it's public now. So I'll leave it at that.
Okay, yeah, we know.
I would think part of the reservoir quality of the Cretaceous may depend on the age of the formation of the trap in the Cretaceous sands or shales. If you got a very young trap and you had a lot of induration because of depth of burial, it could be a problem. So I would expect you to be looking for mainly older traps in sequence.
Yeah, so, yeah. Mm-hmm.
I know you got the Tamana carbonates produced, their Miocene age produced along that central basin, central high there, central range. Do you have no other carbon in production in Trinidad other than that? Am I right?
No, no. Carbonates in Trinidad, they've been just drilled into for water production, right?
Okay.
Yeah.
And I know along Strike, you go way along Strike, the Americair Basin. There's a major field there that's like several 100 million barrels, produces out of the Late Cretaceous carbonates. As I remember, the hydrothermal reservoirs there are somewhat hydrothermal in that they tend to follow fracture systems that come up from basement because it is a wrenched province and develops a lot of hydrothermal dolomites there. Have you seen any kind of hydrothermal dolomization here in Trinidad? I know you said you got tufas. Tufas, I'm very familiar with those. I walked all over them and on the surface there in Nevada. They're pretty much a hydrothermal deposit. But do you see any kind of hydrothermal dolomites or any kind of hydrothermal deposits in the limestones in Trinidad and the wells you've drilled?
No, no. They're not in the wells. No, the wells we drilled targeted all deep water turbiditic sands. And no, there are no reported dolomites in any of the limestones that we have at surface.
Okay, Michael Hines gave you questions. Are the Trinidad Cretaceous sands coming from the Paleo-Orinoco in Venezuela and feeding the delta in the present-day southern Trinidad range system? Not the same as the Iguana Cretaceous sand source sequences. That's what he's asking.
No, it's coming from a paleo river system that is very similar to basically an Olocogen, failed rift that existed prior to the arrival of the Orinoco. The Orinoco system was nowhere near Trinidad during Cretaceous time. Right?
Okay,
the
the shield there, the Guyana shield, I get to call it the Guyana shield there, is huge shield. So you're going to have river systems going off the front, which is mainly kind of to the north or northeast. You got to have river systems going off the east. The ones at the east are what's probably feeding those sands you have. In fact, I'm pretty sure it is the ones you have in Guyana. But what you're saying is the ones that came from that same basic Orinoco shield have come mostly mainly to the north or northeast. Is that correct?
From the Guyana shield, yeah. Mm-hmm.
Okay. So as I remember, you have a big low there that comes right down Columbus Channel. Essentially is that related to an old basement block that sits down there? I've not seen the gravity down. You probably have. But there's a big
that's related to the thick Plio-Pleistocene deposits actually that occur in that area. Yeah.
The whole system, in my mind, when it comes to Trinidad, the whole strike slip motion is being distributed off into a bunch of shears. One of them is the Trinidad and Tobago shear, and one of them is one in through Barbados. The whole thing's fracturing and forming a whole bunch of splinters that are kind of fracturing horsetailers kind of in a way on basement level to the northeast.
Mm-hmm.
Someone else has written down here, Paleo-Amazon before it changed direction in the late Miocene. That's what Patty Walker says. So that's what she's referring to.
No, not Paleo-Amazon, no.
So there's a paper that was published by Lori Suma et al. That basically goes back through the tectonic evolution of the greater northern South American margin. It's a really great reference if you guys are looking for the larger scale tectonic papers. Xavier, your work is exemplary, by the way.
Yeah, there's
so
I like Ken Niblick's paper on 3 rivers, 1 basin. That's a pretty nice one that explains how the Cretaceous play in Guyana, Suriname area works.
Yeah, there is a great summary that was based on a lot of regional work that was done that starts quite a ways back, and basically there's a lot of really good paleogeographic reconstructions as well. So I'll leave it at that.
Okay, are there any other questions?
Yeah, I just had some questions, maybe some food for thought. Really great talk, Xavier. Really appreciate your work on it and sharing with us and everything. It's awesome. You got a slide that's got the string of pearls over in the storybook block and Suriname that shows kind of the paleogeography, the shelf edge and stuff. Can you bring that one back up for us?
You talk about the cave pearls, is that what you're talking about?
No, there it is. The string of pearls. That's what I call these fields in Strabo over in Suriname. I just spent 14 months working on these Suriname discoveries for Stat Soli. Anyway, what I was wondering is, I mean, there's kind of a resolution of age of the reservoirs and of course the source rocks.
Oh yeah.
It's mostly, there's Cenomanian, there's Turonian, there's also some horses over there, maybe even some Jurassic. But the reservoirs mainly on the string of pearls, which are the Strabok reservoirs there that go over together. They're all, it's Maastrichtian, Campanian, Santonian stuff. The discovery by CGX, is similar kind of ages, so kind of, you didn't really talk about what age Upper Cretaceous or even Lower Cretaceous.
No, I said late Cretaceous.
Oh, okay,
Yeah.
so it's
Yeah.
so they're Campanian, Santonian, maybe Cenomanian, Turonian stuff. I'm just looking at this. What really piques my interest is this whole trend, this string of pearls that comes, through the Strabok block and head toward Trinidad. That it's basically a drape of turbidites over a paleocarbonate shelf edge.
And the basin, the
Albion.
basin, this basin was opening in this direction over time, right? So, the basin actually starts opening up over here first, right? And then starts moving that way.
So that paleo drape, that's why you have all those green blobs there, right? You draped a bunch of Upper Cretaceous turbidites pinching out over this paleo high. Really, that's what's trapping them. And I think a critical thing is, where does that go across the Plataforma Deltana? Did it evolve through time? And the questions people are talking about, the paleo drainages, are super important as well, obviously. So you had some rivers depositing your sands in the southern range, in the Cretaceous, Upper Cretaceous.
Yep.
And there's other drainages all the way along here,
Yeah, because there were multiple
captured,
failed rift systems that fed out into these areas, right? Yeah, same occurs in the Paramaribo area. You have a lot of different failed rift systems.
So that paleo drainage system is a critical thing, and the evolution of it through time, across the South America.
The good thing is that we've actually drilled some wells, and we know that there is actually reservoir in the area, right?
Right.
Yep. So we've got that sort of control there. Yeah.
Well,
Anyway.
part of the critical thing may well be, because I'm looking at the Strabok block discoveries and the ones, I guess, in Suriname adjacent to it, is that you don't start picking up those big discoveries until you get past the base of the slope and you're really kind of almost on the abyssal plain. And when you're in that situation, you're not getting prograding beds coming across along the old shelf margin, active thief zones where the oil gets sucked up along those sands in the prograding beds. It's the same way in the North Sea, by the way, and there's deep wells in the North Sea. And I'm looking at what you have on your map there. It looks like just almost right at the shoreline, you develop that base of slope. So if that's the case, you should have some pretty good seals.
Oh no, it's a resolution issue, Steve. I'm not going to show you really high res restored turbiditic fans over here, right? So we put a lot of work into that. This is a generalized cartoon of that. Yeah.
Okay.
And really it's really the important things, obviously, in any of the GDEs are, where was that edge? Where were the paleo drainages and, and the things like the Berbice Canyon cutting across here?
Yeah.
And where is the base of slope? Because so you're getting the lower slope bands versus, a lot of these aren't lower slope reservoirs. They're slope, most of them.
Yeah. And apart from that, like we actually have a fair number of evidence of Cretaceous limestones actually coming up all throughout here within mud volcanoes and stuff. You would have seen a lot of folks have shown those kinds of things come up, these mud volcanoes, right? And some of these limestones actually have lignites embedded in them, and the limestone actually grew around the lignites and stuff as well too. So if they're coming up, these mud volcanoes along the south coast of the country, then where was the shelf edge at that time, right? So
Anyway, very good
Yeah.
thought and interesting stuff. It just kind of piques my interest of what's happening between you guys and
yeah.
Guyana.
Yeah,
Anyway,
thanks.
thank you for the comments and talk, everybody. It's great.
Yeah, it was actually a very good talk, and I like this last map here. It kind of shows the relationship of Stravic's discoveries of Trinidad. It tells you there's potential in Trinidad if you could just keep those things sealed. And I would say the main issue in Trinidad, when you start going to the deep horizons, is age of trap formation and just how well these things are sealed. If you got a weak seal, that would explain, quite frankly, a lot of that stuff coming up into the upper section. Not completely, but a lot. Any more questions, people? I guess not. Okay,
Yes,
so
Steve, I do have a
Yes.
question. This is
Yes.
Steve G10 from Bifrost Energy. First, Xavier, thank you so much for that presentation. With respect to the map that is up, I just want to remind that as we look at the Suriname-Guyanese system, and we look at the yellows that we're seeing over Trinidad, we do have to keep in mind that that's a compressed basin we're looking at. So those yellow drawings really have to be restored to the north. So
Yeah,
I
they
think
are
the big
restored.
question, yeah,
Yeah, they are restored to the north. Yes.
okay. Because, you know, one of the biggest things is as we start putting the wells back in their context, and as we start looking at that reservoir quality, one of the biggest challenges is some of the penetrations were they actually too far north to receive sand, as an example. And, you know, as
Correct.
they were
Yep.
pushed to the south, now we're seeing them in a different position. And do we have to go deeper to start looking for things? So just an observation, but certainly very thankful, Xavier, for what you presented. We're doing a lot of work in this area now, and I certainly would like to get in touch with you to have a conversation.
Yeah, like I said, Bob Ehrlich's map was a nice map, but it was not restored, right? Now we've taken that a little bit further. We've restored everything to where we believe it would have been deposited. So this is a cartoonized, simple version of that restored map. Yes.
Thank you.
any other questions? Okay, I guess not. So I guess basically we'll adjourn the meeting. It's a great talk, Xavier. I learned some more. I always do. I think I know a lot about Trinidad, and I listen to your talks. I always learn more. Okay, that'll be pretty much the end of it. I'm going to go ahead and end the talk. If anybody has questions, you can contact Xavier at his email, or you can go down to Trinidad, talk to him face to face. Nice to see you again,
Thanks.
Xavier. It's been a while. Bye,
Yeah.
people.
Thanks again.
Thank you, Javier. Appreciate the talk.
Thanks,
Yep.
Javier. It was awesome talk, and some doubles for me on Long Circular Road with extra pepper. I missed them.
Okay.
Bye-bye.
Bye.